Welcome, everybody. This is the Community Alert Brokers session that you found yourself in. Right here on this main slide, which everyone should be seeing, the welcome slide. There's a link to the session webpage where there's a bunch of stuff posted, a bunch of resources, introductory resources, a video that Eric made about on behalf of the project, and then also many contributions from broker developers are all on that web page. And then also I put here the Slack channel for conversations and discussions related to alert brokers during this session and throughout the rest of the workshop. So just to start, whoops, that's not what I intended to do. Okay, we should be seeing a slide again about friendly reminders. Someone nod their head. Yes. Yes, thank you. Okay, so the first reminder of every session is that you signed a code of conduct when you registered, and if you need to find this code of conduct, you can do that in the PCW webpage by going to resources in the menu line and then choosing code of conduct. If you do witness any violations, witness or experience any violations of the code of conduct, there are contact people, designated contact people, their names and contact information are provided on the code of conduct website that you can go find it, and please do reach out to them if you need to. The second reminder is that this, as well as all the other talks at the workshop, are being recorded. If you don't want to be recorded, just turn off your video. That's totally fine. The videos get posted usually night of, but at least by the next working day. As we go, we're going to do questions via the Zoom chat and also by the Slack. And in the Slack channel, it's nice. You can give a thumbs up or other positive emoji to questions that other people ask in order to upvote them and prioritize them. And our moderators will bring them up in our conversation. You can also show your appreciation. You can clap for people after they've given a presentation, and just carry on basic side conversations, make jokes, have fun, that kind of thing, all in the Slack. So just want to start with a round of introductions and also tell you about what we're going to be doing today. So I'm Melissa Graham. I work for the data management team at the University of Washington in Seattle. And I'm here with Eric Bellum. If you'd like to unmute, say hi.
Hi, everyone. I'm Eric Bellum at the University of Washington. I'm the alert production science lead for Ruben.
We also have an EPO representative here today, Lauren. I think you're here.
Yeah, I'm here. Hi, my name is Lauren Corliss. I'm an astronomer on the EPO team, and I'm looking forward to this session.
We have two people who are going to be helping moderate the Zoom and the Slack chats today. John and Meredith. John first.
Hello, my name is John Perico. I'm in the data management group at the University of Washington.
And hi, I'm Meredith Rawls. I'm also in the data management group at the University of Washington. I'm also in the enterprise.
Thank you. And then we have two other members of the alert production team who are here today who are going to be helping answer questions and participating in the discussion. Spencer?
Hi, I'm Spencer Nelson. I too am at the data management team at the University of Washington.
And Chris?
Hey, I'm Chris Morrison. I am alert production with data management.
Yes, excellent. Thanks everyone for introducing yourselves. So today's session, we kind of divided it into two halves. And in the first half will be, well, first we have a couple of introductory slides to go over, and then we're going to have pretty much an open Q&A that's meant to be from broker teams and attendees in general to the project staff who just introduced themselves. And then at around the 30-minute mark, we're going to have a set of slides from the broker teams that they've prepared in advance to tell you a little bit about the resources that they've made available to the science community to tell them about brokers and how to use them. And then we'll have a question and answer period between all the attendees and the broker teams where you can ask them, like, can your broker do this or that kind of thing. So that's how we're going to organize this session today. And as we said before, Zoom chat and Slack channel are the best ways to ask questions. We've got John who will monitor the Zoom chat, Meredith will be monitoring the Slack channel, and all the participants will be joining in on the Slack channel to answer questions in real time or raise them here vocally in the call. And I wanted to start because I do see that there's 150 people here. Welcome everybody. And we thought there might be some participants in today's session that don't yet know what an alert is or a broker is, but maybe you do time domain science, so you're here to figure it out. So we have this one slide primer for you. Just want to go over some key terms. So the data management team, the sort of real-time daily processing of the incoming images is referred to as prompt processing, and is based on difference image analysis. And that's what these three like little diagrams are kind of showing you here. Difference image analysis is when you have the old template image, you take a new image, you subtract the two and you get a difference image. When you do source detection in your difference image, you find DIA sources. That's a single detection and a single difference image. The collection of all DIA sources that are at a given location on the sky, that's a DIA object, linked by coordinate. All of these catalogs of DIA sources and objects are stored in what we call the prompt products database, which you might hear referred to as the PPDB. And then within 60 seconds of an image being taken, every DIA source instantiates an alert, which is basically an ASCII packet of information of everything that LSST knows about that particular DIA source. So this stream of alert packets goes to the alert brokers. The brokers receive and process these alerts and make them available for users to interact with, filter, search past alerts, do science with the alert contents, that kind of thing. So that's DIA sources, DIA objects, the PPDB, alerts, and alert brokers. The other part of prompt processing is also the release. The release of the images within 24 hours and also updating the DIA source and DIA object catalogs within 24 hours. So that's a very quick list of jargon, words you might hear today. On the session webpage for this alert broker session, I posted a couple of resources to additional slide decks and parts and documentation relevant to alerts that you can go and read about. But also I want to emphasize that your basic questions are completely welcome, especially through the Slack channel. Today we have people standing by. Do not hesitate. You can ask again, what is an alert? That'll be fine. Okay, so I want to hand it over to Eric here to speak a bit to broker selection and alert simulation.
Great. Hi, everyone. This is just a short one-slide summary of some slides that are posted again on the session webpage. So feel free to browse through those for more detailed discussion of all of these. And there's also about a 20-minute pre-recorded talk to add to your stack of recorded talks. So I just wanted to extract sort of the key points for those before we head into Q&A, actually, and a slide or two on EPO. So the topics to discuss are alert broker selection, sample alerts, and possible alternative architecture for alert distribution. So there's not a great deal to report right now about selection of community alert brokers. These are the teams that are going to receive the full alert stream from Rubin once it's operational and make the data products available to the community and add a lot of value with services and so on. We'll hear more about that in the second half of this session. And so last December, we put out a call for full proposals that followed a letter of intent process that happened the previous year. And so we had about 15 teams which were invited then following that letter of intent process to submit a full proposal. And in an alternate universe where we spent last night sitting around the pool together in Tucson, chatting with each other, I had hoped that today we'd be able to announce what those selected brokers would be. But obviously, due to all the upheaval due to COVID, we chose to delay the due date for those full proposals to December 15th of this year. Originally, and still, we had said that the due date could be pushed back even further if circumstances warranted. I think at this point we're intending to hold to that date, but obviously 2020 has already been a very eventful year. So those proposals will come in from the team. Some of the teams you'll hear from later in this session, and the LSST or the Rubin Science Advisory Committee will form a committee that will do the actual selection, and we expect those in about the second quarter of next year. So the primary reason for that delay was, again, all of the upheaval due to COVID in the first part of this year. But we also were a little late getting together some sample alerts that we had promised the broker teams to sort of help them develop their systems. But those are now available both to the broker teams and to the broader science community. So just in brief, what we've done is we've taken some precursor data from initially from the HIT survey done with dark energy camera. We've processed it through the Rubin data management pipelines and produced alerts with the formats and content that we expect for the eventual survey alerts. So those are available. The link in the slides will point you to that information. There are a number of caveats. There are many parts that are incomplete. We simply have not written all the software we need to do things like trailed source fitting or spuriousness classification. We haven't defined exactly what the time series features that will be included in every alert are. And so there are some missing pieces, but in terms of having real data and a real sense of what the pipelines are delivering today, I think they're very useful. So we expect to continue to reissue these and update them as we fill in those missing pieces and approach sort of the commissioning period. There is also, as part of this release, a stream simulator developed by Spencer Nelson, who's here on the call, which is sort of like Kafka in a box, and it enables broker teams especially to take those simulated alerts and to sort of produce on their own machines simulations of the streaming sort of architecture that we are baselining as we think about alert distribution. I don't think that the stream simulator is probably of great interest to sort of general scientists trying to understand what's in alerts, but you're certainly welcome to poke at it and take a look. Finally, I just wanted to raise briefly a topic that has come forward again. This is an idea that I think has been around a while, but again, prompted by Spencer joining us and sort of taking a fresh looking at with fresh eyes at our alert distribution architecture. We're thinking about potentially, and this is just an idea at this point, but we want your feedback, looking at a alert stream that would separate sort of the initial notification that a data source has been detected from all of the sort of value-added information that Rubin provides in terms of the alert history and the cutouts and the all of that sort of additional information. And the reason for that is that as we are currently planning, we're sending these really enormous alert packets that can be 100 kilobytes or even into megabytes, depending on how large the cutout is. And that's very technically challenging. It uses a lot of bandwidth, makes bandwidth a constraint. And that's part of the reason why we only have sort of a small handful of alert brokers who can receive the full real-time stream. So the idea of this alternative architecture is that we would strip down to just a bare minimum of sort of the key parameters that tell you about an alert, what time it was, where it was, a little bit about the context and its past variability. When was the last time it was detected, for instance? Enough that as a science user, you could then say yes or no, this might be of interest to me, and then go retrieve that additional information from a separate source. So the idea is that we would still have the full alert packet with all of the contents that are promised today, but you would pull that if you thought you were interested in that alert, rather than sort of being required to receive every alert. So this sort of thin notification stream could then be distributed much more broadly. You could run it on your laptop if you wanted to, and then you could reach back and get the full alert contents if you needed them. And then in this model, community alert brokers still function as they do today. They just have sort of special permissions to be able to retrieve all of those full alerts in real time within that 60-second latency window. So again, this is still at the early stages. It's sort of at the stage of a whiteboard sketch, and we'd really welcome your comments on this, both in this session and at other times, as well as your feedback on the sample alerts. And we're encouraging folks to use the data Q&A section of the community.lsst.org, which is again linked on this slide.
Thanks, Eric. So that that link where it says "Are welcome," that takes people to community. Is that right?
Yes, that's right.
Yeah. Okay. Great. Great. Thanks. Okay. I do see some questions are starting to come in, but we just want to round out the messages from the project part of this with a message from EPO, and then we're going to go to questions after that. Lauren?
Yeah. So just quickly, I wanted to provide some of the EPO context in addition to the technical context of what we're doing. So EPO has a bunch of main early goals that involve generating excitement about the observatory. And we're particularly interested in using the alert stream to highlight how Rubin is observing the changing sky. But something to keep in mind is that we're doing this for the general public, and alerts alone will generally not be interesting to them. They're not used to looking at difference imaging analysis and understanding that the little flickers that they're seeing is actually something that's incredibly exciting. And so what we're looking to do is rely on the brokers for some of this added value, like science classification and interpretation of what the alerts are showing, so that we can use that as context for the alerts and to build narratives. So a flickering picture maybe isn't interesting, but if I can tell the story of, oh, that's actually a star that exploded in a galaxy that's this far away, that maybe has an AGN that's flickering inside of it, that's now a context that people can be excited about. And we're particularly interested in trying to make this like a pretty rapid kind of a turnaround of like highlighting the fact that, maybe this thing happened yesterday or it happened 2 days ago as a way to generate excitement for the work that we're doing. So just to be a bit more concrete about some examples that we're thinking of how we'll use the alert stream. So we're building an all sky image viewer to sort of present the entirety of the Rubin survey and images to people. And you can imagine having things like an overlay on this sky viewer, we're calling it. You can see a mobile prototype here where people can understand like, oh, this is a new thing in the sky that happened maybe a week ago, and building that into these sorts of products. Including things like counters or dashboards to demonstrate the sheer number of discoveries that we're going to be making. So I've also included a little screenshot of the website that we're building for operations here. It's like solar system objects found, and broker classifications is a stand-in for whatever classifications or information we're going to be getting out. The idea of collecting things of transient discoveries of interest that we could post to social media pretty rapidly. So there's a lot of exciting ways that we can use this time domain element of the survey. And in general, I just want to note that we're beginning to develop the backend infrastructure that's going to support these products. So actually being able to receive some of the data that's being generated by the alert stream and pass through the brokers, we're now going to be building the infrastructure for. And so I'm looking forward to hearing more about what's on the table and how we can work together in the future.
Excellent. Thank you, Lauren. Thanks for presenting that. And so in the future, you might send emails or make posts on community for brokers to talk with you about these kinds of things, that kind of thing. Yeah.
Yeah, that's right. So reaching out across multiple communication channels to try and get input.
Excellent. Okay. Cool. Thank you. That brings us to our first Q&A session. So I think we'll go first to Zoom for questions, then for Slack, and sort of alternate back and forth until we reach sort of the halfway point of this session. So first, John, on the Slack chat, can you pick out a question to ask for us?
On Zoom. Yeah.
Sorry, Zoom. Yeah.
So I guess there's a bunch of questions about sort of what exactly lightweight packets are, whether there might be lightweight solar system packets, and does it mean that there could be more brokers available? I don't think that was, some of the questions were answered here, but I don't think that one was. So are there, with the lightweight packets, is there a plan to allow more brokers?
Yeah, I can take a pass at this. So I think I want to emphasize first that this is an idea and a concept, and one that you know, we're refining with your input. And so I think there's the fundamental statement I think to start from is that we're required to support at least 5 full streams to community alert brokers. And that implies that that's coming from sort of a bandwidth budget, an estimate about the size of the stream, and so on. And so that is what I expect that that is the minimum that the broker selection committee sort of must deliver. If we move to this sort of lightweight packet architecture, I do believe that it opens up the possibility to have many more community brokers, many more individual scientists who receive that full lightweight stream, which is again consisting of notifications of every data source. So it's every alert. It's just a subset of the content. And then you know, the question of whether there are more than 5 folks with sort of rate limits that allow them to receive the full stream, I think depends somewhat on things that we don't know very well right now, like where is the US data facility going to be, and you know, what is the sort of specific network environment. I can certainly envision that, you know, you have, I'm making a guess here, but it seems plausible. You know, again, that sort of 5 full that number of 5 brokers is coming from a desire to get that get all the alerts out of the data facility to those brokers within our 60-second window. But there certainly is time available after that where you know, other teams could be picking up alerts outside of 60 seconds within, you know, 90 seconds, for instance, before the next visit starts. And so you could envision sort of a tiered approach if that is the best way to do it. But to some degree, I think it's hard to reason about until we see the full proposals, until we see how many you know, how many proposals come in, and until we understand more about the data facility.
All right, I can jump in with a
Thanks,
question.
Mary.
Oh.
Yes, please.
Okay, I can jump in with a question from the Slack. This was discussed a bit in the Slack subsequently, but I still think it bears repeating. Lots of questions about what criteria or rubric will be used to select alert brokers past second stage, or what sort of basic minimum cut will be made.
Yeah, I pointed in the Slack channel as well to LDM 612, which is a document handle that the link is there that you can retrieve it, which I suspect the broker teams have all seen, which sort of gives some general ideas about how to think about broker capability. But I would say that at the end of the day, really the SAC is empowered to make this decision how they want to, with their holistic view of the ecosystem, the science context, and so on. And so, you know, I'm not a part of the SAC. I don't make that decision, and so it's really up to them how they approach this.
We can go back to John for another Zoom question.
Yeah, I think this was answered a little bit in the chat, but could someone walk us through a use case where, say, a new supernova is discovered? So, you know, what are the stages? I assume the broker synthesizes the information from the alerts. Do they then announce this via a transient name server? As a user, what do I do? Where do we get information via an API provided by the broker?
Sure. That's a great question. There's, I think, a lot of field-specific conventions around discovery and reporting that we're still, I think, working out. And I think we'll hear a little bit in the second half of this session about some of the things that are happening with ZTF in terms of reporting transients to the transient name server and so on. So from the point of view of Rubin, we run difference image analysis and detect DS sources and make alerts without really any particular regard for whether a source is a new supernova or a variable star we've seen for 8.5 years. And we issue all those alerts and they go to brokers. And so some brokers may have sort of pre-built sort of scientific classification filters of the sort you're describing that might say, this is a new supernova, let me tell my users about it, let me tell the subscribers to this channel, let me post this to TNS. Whereas others may sort of let their users sort of on their own decide what's interesting, and that can be manual or automated or so on. So I don't think there's a single answer here. I think you're going to see everything from highly automated workflows with large teams to individuals who are sort of looking through a tiny subset of the millions of alerts by eye and saying, this is something that everyone needs to know about. Let me type up a circular, an astronomer's telegram or something.
All right, stop us when we should stop. I'm going to jump in with another one from Slack, if that's okay, Melissa.
I was just going to invite you to do so.
Perfect. Which of the candidate brokers are currently actively developing tools for solar system moving body science? That might be a question yeah, go ahead.
Yeah, there's certainly the SNAPS broker, which we'll hear about in the second half. I am not immediately aware of others, but I hope that someone will pipe up if they know of it. But I guess I would add, just based on a brief comment that went by, I think, and was answered in the Zoom call, that in the lightweight alert model, we would still send out lightweight alerts for solar system objects, and they would be tagged as such, and they would have all the content available to do all the solar system science you can do with alerts.
If we still have time, I think there are several more questions on Slack than on Zoom. So Meredith, do you want to pick a few more?
Yeah, I can do another one. There's like 7. Okay, why not include the light curve itself instead of its features into minimal packets? There was a little bit of elaboration here. A half-year light curve is only about 40 observations times 4 bytes times 3 for the errors and whatnot. So that's like 480 bytes of uncompressed data, and it could be even less if we don't include upper limits.
Yeah, it's a great question. So I think there's a trade-off to be made, and I won't claim to know what the right answer is here. Obviously, you can always add more useful information to the alerts until we get back to where we are today with 100 kilobyte or larger alerts. In my mind, certainly, and again, I want to credit again Spencer for encouraging us to think about this seriously. The point of the notification stream is not to be sufficient to do all the science. It's just to give you enough of a hint that you might be interested, that you can query back to the full alert packet and retrieve that, and to do so, provide enough information that individual users can fit within a comfortable rate limit, and so there's certainly a trade-off there. We would certainly include some light curve features, some simple ones that would let you, again, quickly characterize, like, is this a variable star? Is this a supernova that no one has seen before? That's something we can capture in just a few numbers rather than 80 or 100.
Can I do one more quick one? Given the cadence of the telescope, what drives the 60-second requirement the alert is issued from close of shutter?
I don't think it's extremely strongly science motivated. The Transients and Variable Stars group has done a survey asking about science drivers. It's a it's I think basically, you know, an encouragement for us to get the information out as quickly as we can and enable rapid follow-up.
I can keep going.
Since we're at the halfway point
Okay.
now, I'm gonna switch over and let the brokers speak for a little while, and then I'm sure that will inspire many more questions. And so if you do have any more questions for the alert production team or project staff, just pop them in the Slack and we'll get them answered for you later. And so now, I did originally tell the brokers that I would give them 30 seconds to speak, but I can't actually time less than 1 minute, and there's only 10 of you. So I think 60 seconds, you'll each get 60 seconds, and then you'll hear a timer from me. So you get twice as much time. I think that'll be okay. And so all of our attendees who are on the line, I have some example questions, especially if you're quite new to brokering, things to think about that you might want to ask the brokers. Like how brokers do various functionalities. What do they do now versus what they'll do in the future? Whether your particular object of interest is particularly supported by one broker or another, or whether, for example, which brokers ingest data from other types of facilities that might be, you know, of special interest to your science. So the kinds of questions I thought you might want to ask of the brokers after they give their 1 minute little presentations. So I'm about to just go. I'll put up the slide there in whatever order you put them in, and then just unmute and speak to your slide until you hear the buzzer. Okay. Who do we have first? Nina.
So, hello. Our broker is, we call it a point of interest variable alert. This means getting updated variability features and detected sources in a predefined area on the sky. This is the special thing about that. With predefined, we mean something the user is interested in. This could be a selection of known stellar streams, dwarf galaxies, and so on, or something the user is creating. So individual stars, the user is interested in getting repeated update. And this will be helpful in exploring the trends in the optical sky, and also, of course, mapping the Milky Way when it's based on specific variables such as outlier stars or Cepheids.
Okay. Thank you, Nina. That's what the timer's going to sound like. Okay. Antares.
Great. So the Antares broker has been around for a little bit more than 1.5 years now. We have a shiny new version that's been informed by feedback from all of you in the community that have told us things. Many of the changes are to the back end of the Antares system so that we are scaling from ZTF to LSST. We've moved, for example, from MySQL to Cassandra and got a much more robust Kubernetes implementation that's currently deployed. But there are some changes to the front end to make life a little bit easier for you. So you can now search by ZTF object ID and soon by TNS ID or our own Antares internal ID. You can favorite particular objects when you look at their light curves. The cone search functionality is sort of right up front and center to you. We have more static sky catalogs for you to cross-match against. You can, of course, write your own Python code, and we will run it in our pipeline for you. You will get a whole stream of alerts, including alerts that are in some particular region, for example, through a Python client library or through the web interface directly. And we're currently working on with the LSST desk broker team and serving different groups like the Young Supernova Experiment.
Thank you, Antares. Lesser.
Hello, this is from the UK, from Edinburgh and Belfast. We share many similarities. We are building a platform for others to do science rather than doing our own science. We are ingesting Kafka, putting Kafka between our components, and outgesting Kafka as well. And we are intending to add value in many ways. one of the central features of LASA is that there is a static query mechanism to see what has happened in the past, together with web interface, API, Jupyter, and that very easily converts to a streaming query interface, which generates Kafka in real time and makes logs, and you can even get emails if you wish. So this is our main shtick here, is SQL that can be either static or streaming. We add a lot of value, the intelligent cross-match from Sherlock, features of the light curves, watch lists, favorite sky areas like gravitational wave areas, cross matches with TNS and so forth. We have a way of adding arbitrary different kinds of classification engines into our alert stream, lots of sky map tools, and you can add comments, don't show me this one again, and stuff like that. Up at the top right, there are links to all sorts of information. Please give it a try. Thank you very much.
Thanks, Roy. Next up is Fink.
Hi, I'm talking about Fink. So Fink is a young broker that we started within LSST France a year and a half ago. We have a prototype already deployed in the cloud, and we are ingesting the CTF alert stream. One of our big features is that we are a big technology. We started for LSST, so we develop all this technology thinking about LSST. So we have tested beyond LSST technical needs, and we just started with the LSST alert samples. Now our first modules, science modules, are available now. We are filtering the CTF alert stream to detect from supernova to microlensing to GRBs afterglows, and doing real-time cross-matching with CDS. And we're trying to implement the state-of-the-art science models, but it's a community-driven effort. So we want to hear from you. We want to hear from science collaboration requirements. For example, we're talking with the desk topical team about selection functions and reproducibility because we're in a 10-year survey, and we're working on interfaces right now for the community. So that's it. Thanks.
Thank you, Fink. And I just wanted to pause for one moment and remind people that many of the brokers have prepared presentations and video presentations and have links to their websites on our session page. And if one of our moderators can pop the link to the session page into the Zoom chat for people, that would be great. So thank you very much, John. Lots of information there. Whoops. Yes, okay, great. Next up, Alersi.
Thank you. Hello, I'm speaking on behalf of the Alersi broker. Here you can see a summary of our most important results and products. We have both an image and a Litecore-based classifier with different taxonomies and which have been used for more than 1 year to classify the CTF stream. We have two web interfaces, the Supernova Hunter to discover young supernova in real time, and the Explorer to search and visualize objects. Our interdisciplinary team has built a modular and flexible pipeline. We have prepared notebooks centered around different science cases for our worldwide user community. Please visit our website to learn more about our products. We have released previews of our first 3 publications in archive, as well as a preview of our new database, redesigned after a year learning from CTF. And we would like to move it into production. So we would like to hear from your feedback. Thank you.
Awesome. Thank you, Francisco. Thank you, Team Alersi. Ample.
Hi, everyone. I'm Jack Norden. I'm here representing the Ample team. Ample was started to be designed a few years ago for a few varying science cases that we realized we didn't have tools to do as well as we could. So they have to do with doing complex calculations on heterogeneous data streams, having kind of solid real-time reactions, and doing consistent sample studies where we can go back and forth in time and study selection functions and photometry updates. So Ample was designed to do these things. To do this, we have to implement different stream operations. So not only broken data, but also join data streams and supplement kind of static or determined alert streams. This means that there's no single output, but rather if you want to know how to use AMPL, then just contact us on the email there on the bottom, or if you want to use the ZTF data.
Perfect. Thank you, AMPL team. INAF.
Yeah, hi everybody from Italy, from the Italian National Institute for Astrophysics. Basically what we did was a survey within our institution about our scientific needs for a broker, and we realized that most of our scientific needs are already covered by the market. For example, our transient community is historically linked to, for example, to laser. But still, there are a few scientific cases that may need some very specific products. So we made an internal call to test available brokers on this listed topics, and we will end our survey within the end of August. Of course, some of them could be satisfied by the lightweight stream. And that's it. Thanks.
Thank you. Perfect timing. Oh, class.
Hi, folks. So I'm representing the Canadian LSST Advanced Science Platform, or CLASP. I'm putting a lot of information about CLASP on here. It's actually the kind of community broker functionality is one part of CLASP, but we're designing this as a science platform that will enable access to LSST data, both the alert stream and also the static data for the Canadian community, but also to potentially serve as an archive within North America. In terms of the alert broker, we're again, and similar to the INF broker, we don't want to reproduce the functionality explicitly, but we will take the output from some of the broker streams, like something like Antares. We will work on doing cross-matching and classification with additional Canadian held telescope data and other data sets, including radio data at the source. And then we will develop some pipelines integrated with the science communities to be able to do science with LSST alert streams in combination with other data types. If you're interested in learning more about this and our kind of Canadian proposal for LSST data access, then please contact me and I'm happy to share more information. Thanks.
Thank you, Renee. The Pitt Google broker.
Hi, my name is Troy Rayne. I'm a graduate student working on backend development and also the piece that I'll talk about today, which is the Bayesian meta classifier. I've had discussions with folks around here and fleshed out some of these ideas, and I'm looking forward to actually building it once we get the back end to a good stage. I'm currently looking for one or more good science cases to drive the development, so I'm interested in hearing from anyone with ideas. Our broker, like others, will have a lot of information available, including alert data, data from cross matches, and classifications from what I'm calling targeted classifiers. So these include classifiers targeted at supernovae or variable stars, etc. The Bayesian meta classifier would make classifications by simultaneously considering those pieces of information and maximizing the joint posterior probability. This is in contrast to what seems to be a more standard approach where brokers make a series of decisions on questions like which cross-matched redshift is appropriate to use for objects with multiple matches, and do I think this is a transient or a variable star, and which targeted classifier should I run or trust? The Bayesian meta classifier would instead learn and then be able to explore the space of the full joint probability of all that information, including the classifications from targeted classifiers, and use it to make class and redshift determinations. So if this is interesting to you, I'd love to hear from you.
Thank you. Snaps.
Thanks, Melissa. Hi, everybody. I'm David Trilling. I'm going to briefly tell you about SNAPS, Solar System Notification Alert Processing System. This is a broker to ingest solar system object observations. I have a little schematic shown on the right. We ingest an alert stream either directly from a Sky survey, so ZTF or LSST, or we can, as we do now, listen to a substream. So Antares rebroadcasts a solar system substream, and we're listening to that. We have a database, of course, and we are producing both real-time outlier detections, that's the red channel on the right, and daytime outlier detections, that's the blue channel on the left. Let me see, so on my key points here, we're presently ingesting from ZTF as we have been for 2 years or whatever the number is. As I mentioned, real-time outliers, alerts issued. We have a value-added database that will soon be publicly accessible, and we have end-to-end testing with the synthetic population as well. Thank you.
Thank you, David. I think, yes, that was our last sort of flash slide from the broker teams. So just want to remind everyone that these slides are posted on the session webpage along with all the extra resources provided by the broker teams. If any of the broker teams still want to add stuff to that webpage, resources, we still can, just let me know. And before we go into our Q&A session, which I want to take us to the end of the session, so I want to invite, I think, Francisco to speak to this slide.
Anais, I think will.
I'll go for it. So we wanted to share with you that we are organizing a workshop for this whole theme about the alert brokers and LSST. So the idea is that we're gonna do 2 mini workshops, 4 hours each, virtual. The first one will be at the end of October, and the next one will be 4 to 6 months later. But the idea is that the first workshop, we will talk a little bit more about the brokers' present goals and the status. We want to hear what the science collaborations are thinking about requirements, specifically like subgroups of the science collaborations, and also, of course, from LSST. And then once we set up this baseline, we will do a second workshop where we can actually do tutorials, answer some of the questions the science collaborations have had, and users can bring their detailed science cases so we can try them out. And the idea is to be like a community repository and collaboration between all the brokers, teams, and the science collaborations. So we need your input, so let us know. And we hope that you will be there joining us.
Great, thanks, Anais. This is like really exciting. I'm glad you guys got that grant. Congratulations. All right, we're back into Q&A mode. So use the Zoom chat, use the Slack channel, and let's do the exact same thing we did before and invite John first to bring forward a question from the Zoom chat, if he's ready.
Yeah, so there was a really good question here, which was partly answered in Zoom. I'll read the question and part of the answer, but I think this should bring up some discussion. If someone creates a public specialized filter, for example, the supernova classification filter for a broker, how does that person get credited? Is there a tag to tell users to cite the appropriate works in addition to the broker itself? There's a couple of answers saying that it's broker specific. In one case, each user creates a stream and publishes results that are responsible for defining their own publication policy. Someone else said that you can set properties for objects that your filter processes, including citation DOIs, and that metadata will get propagated through. But I think this is something where Rubin could provide guidance to the community on how to go about this. So this is, I guess, both as questions for individual brokers, how do you handle this? And for Rubin as a whole, is there guidance on how we manage the community aspect of ensuring proper citations for brokers?
Oh, I was a little bit distracted by the Zoom chat myself. Was that a question for Eric, or is this where like any broker?
I guess we could start with Eric, but any broker, if you have input into the question of citations for filters and such, filters and brokers.
I don't think I have anything profound to add here other than, this is an important question to think about in this ecosystem that's very distributed. It's certainly a topic with a lot of heritage. I'm sure that there were lots of discussions around this in the VOVN era and mechanisms proposed there. But I think it's really a community-driven consensus is the way forward here.
Do any of the brokers want to provide input in how they're handling it?
I responded to Ashley partly in chat and talked about sort of setting a citation DOI that we can propagate forward, but we can do a little bit more. So Antares, which I'm representing here, we don't currently report discoveries to TNS, though we actually do classification. And the reason is actually partly related to this. We don't want to be seen as taking credit for somebody else's hard work. We can write our own filters, and as a result of that, certainly we can report to TNS. But I think maybe the thing that we do is provide some API calls for any filter to report to TNS, setting the author list appropriately there. So for example, say Ashley's SN filter simply calls a function that says report to TNS, and it provides a string with an author list inside the filter itself. So whenever that filter trips on some particular alert, it's recorded as Ashley reported this to TNS. And that's one way of ensuring that credit happens within the entity system itself, rather than we just propagate the DOI and then rely on the rest of the community actually citing that in their papers. This way it actually guarantees that there's a discovery record, discovery report in TNS. And I don't know if anybody has thoughts on that or if that's like reasonable or acceptable.
So I think formally, philosophically, this is impossible because you're going to be joint classifications with a bunch of different stuff. But I also totally agree with the question, and it's an important thing to try to figure out. I very much hope maybe that we can have some more discussion about this at workshops that Anis and Francisco are doing. I think that this is a great thing. Thank you. I hadn't thought about this before.
Can I comment?
Yeah, yes, please.
Yeah, so regarding the reports to TNS, I think this is it's a very flexible environment now. It's changing, and actually because of this, there was a new column in TNS, which is the reporter and the discoverer and the source, right? And I think if we don't put it in TNS, this will be lost. This information will be lost. So I think we need to go where to use what the users need. And I'm not sure the users are ready to actually listen to the stream, the classified stream. I think it's being practical in this case. But I agree that the credit should go mainly for the survey. And we don't change the ID, and we put that is actually discovered by CDF in our case.
I'm just going to pause for 5 seconds and let someone else jump in with a final thought on citations before we move to another question.
This is Andy, if I could. I mean, there's been some very interesting specific things about how brokers will handle the details of this, annotations and so on. I think we're missing the big point, which is that this is a huge issue in the community in general about how we credit databases, workflows, software. It's a very big problem. So the more general community guidance we can have on what's appropriate in the future, the better. It's just not a technical issue. It's really a kind of philosophical issue. It's partly a technical issue as well. There must be something equivalent to a DOI for crediting such things. And so these things are very fluid in the community, in the scientific community as a whole now. How do you publish a Jupyter notebook? What does that even mean? So I think we can't solve this in the absence of understanding those general issues.
Excellent, thank you. All good points. Let's maybe go to Meredith and switch to a new topic, perhaps from Slack.
Sure. So to switch gears slightly, from the point of view of a user who might be interested in receiving like the full alert stream, are there considerations for choosing at least one broker which will commit to retransmitting the full stream, even if this is like a paid service?
Sounds like an Eric question since it mentioned the selection process.
Yeah, so I'll repeat some of this discussion happened already on Slack, but I'll try to summarize very briefly. Because the community brokers are not funded by the Rubin project, my feeling is that it's not, we don't really have a strong lever arm to say you must do this or that. We've done everything we could to encourage teams to provide that sort of functionality in order to be selected. But I think that we don't have a huge lever arm here, and I am confident that the SAC will approach this with when the selection process with a view to enabling the broadest science, especially because alerts are the immediate world public product, and we want to make sure that that's indeed available.
And I think if individual broker people have plans to do this or thoughts about this, there's a thread on Slack where you can add your specific intents or ideas. So if it's all right, I'll move on to another one. Or John, did you have one?
That's correct.
So there was, excuse me. I think the only question remaining is how we consider feedback from observations not associated with big surveys. So someone observing on some other telescope, they need to know what to watch for and how to report back what they've found. If they're not hooked into a bigger institution.
So like how can users report classifications to brokers, sort of, is the question?
I think so. This was from Peter Kubanek.
Okay, I'll let any broker team jump in.
Maybe I can, this is Jacob from Ample. Yeah, so this, in our language, this would be the combining stream operations, where you're free to add other external data set and then describe triggers for what you want that to happen, if you want it to be published or if you just want to have it joined with the LSST data streams. So I think this is something that I think is will be very important, and I think there's a lot of potential for what can be done here. Technically, it's a bit hard because you need to have a policy for how you combine data from different objects, whether you associate them with position and how you want to do that, and then what you call these things. But there are solutions to all of these things. But it requires some work.
Just leave it open for a moment if any other broker wants to jump in on how users provide information to the brokers. Silence is fine. Can continue it on Slack. Meredith, would we like to raise another question from the Slack?
Yes, so there was a little discussion again on the Slack because you all are very chatty, which is excellent, but I want to raise it here as well, about the lightweight notification streams in particular. So this is for, I guess, Eric and friends. When will a final decision be made about the lightweight notification stream, like timescale wise? And then related to that, will it include postage stamps?
Right. So you can't put. I don't think we can put the stamps in the stream and still have it be lightweight. They're just too big. There's a very good question of, how do we draw the boundary between too little information and too much? And I think that's both technical and scientific. And so I would expect that we on the project would make a sort of initial proposal and send that to the science collaborations for comment and feedback. In terms of decision-making timescales, for various reasons, I don't expect us to really dig into technical implementation if we were going to do this until early next calendar year. But if the feedback on this idea is positive, which it seems broadly to be, maybe I'll put a poll in the Slack channel, then I would expect to use sort of the remainder of this calendar year to have more formal conversations with the various stakeholders, the SAC, the many acronym stakeholders that care about Rubin Observatory and would like to provide feedback, because this is it's a fairly fundamental change in terms of the structure of the alert stream, even though there's no change in the contents themselves. And so, the alert contents themselves. So I don't really expect that to converge prior to the end of the calendar year anyway, especially given COVID.
Yeah, sneak in with one final one, or are we at time?
We are at time.
No worries. There's a whole Slack for more questions.
The whole Slack, please continue. It sounds like a lively discussion is already happening there. So since we're at 11:30, I'm going to thank everyone for coming, listening, participating, for all the brokers for providing all of those resources, which I really hope new users will go and check out. And yeah, thanks everyone for coming. Have a great rest of your day or night.